Hi students, welcome to my YouTube channel Dharmadas online classes. Today I will discuss linear differential equations with constant coefficients. Before this, I have discussed it in lecture 1. This is my second lecture. First, the other day I finished with how to find the complementary function of a second order linear differential equation. Today we will learn third order linear differential equations with constant coefficients, how to find their complementary functions. Let's see how to find it. Let the differential equation be given by d3y dx3 plus p1 d2y dx2 plus p2 dy dx plus p3y is equal to fx. Now here p1, p2, p3 are constants and fx is a function of x only. Okay. So for its complementary function, we will assume a trial solution. Let's suppose y is equal to e to the power mx be a trial solution of the differential equation 2. Look here, what was fx? Okay, fx. So when we find the complementary function, we take fx as 0 and the equation we get, meaning here d3y dx3 plus p1 d2y dx2 plus p2 dy dx plus p3 into y is equal to 0, we'll get this equation. Its complementary function must be found, because a complementary function can always be found for a linear homogeneous differential equation. So for that reason, here we have taken 0. So if y is equal to e to the power mx is its trial solution, then if I put the values of dy dx, d2y dx2, d3y dx3 and y in equation number 2, what will I get? If we differentiate e to the power mx once, we get m into e to the power mx. Twice, we get m square into e to the power mx. Thrice, we get m to the power 3 into e to the power mx. So after putting those, we'll get m to the power 3 plus p1 meter square plus p2 meters plus p3 whole bracket into common into e to the power mx is equal to 0. Here, see, e to the power mx is not equal to 0. Okay. E to the power mx is not equal to 0. So the solution we got is m cube plus p1 m square plus p2 meters plus p3 is equal to 0, which we'll call the auxiliary equation. I have said this before in the previous lecture. Now this is a polynomial of third order. Third degree. So how many solutions will this have? It will have three solutions, three roots. So what can those three roots be? It will have three roots. What can those three roots be? Well, all three roots can be real. Okay, when the three roots are real and unequal, let's assume the three roots are m1 m2 m3, real and unequal. In that case, its complementary function will be c1 e to the power m1x plus c2 e to the power m2x plus c3 e to the m3x. Okay, now we will get other cases where two roots will be equal, real and equal, and the third root will be unequal. What happens then? We are naming that case too when two roots are real and equal and the other is unequal. Say m1, m1 and m2. So in that case, what will the complementary function look like? As I have already mentioned before, when two roots are real and equal, in that case, its complementary function is c1x plus c2 into e to the power m1x. Okay, and for m2, which is different, it will be plus c3 into e to the power m2x. Okay, what will happen in the third case? When all three roots are equal, real and equal, when three roots are real and equal, say m1, 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 so in that case, what will the complementary function be? c1x square plus c2x plus c3 into e to the power m1x. And the last case, which is case 4, in that case, if we observe that for any third degree equation, three roots exist, then if those three roots are found and if there is a chance of them being complex, then they exist as complex conjugates. Okay. Because if an equation has real coefficients, then if its complex roots occur, then the complex roots exist in conjugate form in pairs. When two roots are complex conjugates, three roots can never be complex, okay? If there is one complex root, its conjugate will also be there. So when two roots are complex conjugates and the other is real, say, so one is alpha plus minus I beta, meaning two. One is alpha plus I beta, its complex conjugate will be alpha minus I beta. These two will be together. And the third one is m. So in that case, the solution, the complementary function will be e to the power alpha x a cos beta x plus b sin beta x plus c e to the power mx. Okay. Now we'll look at some problems. Let's look at some problems. I have shown some problems here. Problem number 1, solve 3d squared to y dx2 plus 8 dy dx plus 4y is equal to 0. So first what we will do is we have to consider a trial solution. So let's assume that y is equal to e to the power mx be a trial solution. So in that case we'll get the value of dy dx. The value of dy dx will be m into e to the power mix x. d2y dx2 will be m square into e to the power mix x. Okay. So if we put these values in the differential equation, we'll get e to the power mx into 3 meters square plus 8 meters plus 4 is equal to 0. And e to the power mix will not be equal to 0. So 3 meters square plus 8 meters plus 4 will be equal to 0. This is our auxiliary equation. So here we will solve this quadratic equation. If we solve this, what will we get? M plus 2 into 3 meters plus 2 is equal to 0. So the value of M will be minus 2 and minus 2 by 3. So what will be the solution? The solution will be, well, we have already said that the solution pattern for any linear differential equation will be complementary function plus particular integral. Okay, and the complementary function is found by making the right side 0. Now, if the right side of the main differential equation is 0, if there is no fx, then in that case, the general solution will be, the complementary function will be its general solution. Okay, so in this case, that's why solution means general solution. The general solution will be y is equal to c1 e to the power minus 2x plus c2 e to the power minus 2 by 3x, where c1 and c2 are arbitrary constants. Okay, let's look at some more problems. I've written another problem here. Solve d2x dt2 minus 4dx dt plus 13x is equal to 0. Here there is no dy dx. What we have is dx dt and d2x dt2. So in this case, instead of writing y, we will write let x be equal to e to the power mt, be a trial solution. So what will be the auxiliary equation? Therefore, the auxiliary equation is m square minus 4 meters plus 13 is equal to 0. So from here, what is the value of m? If we apply the Sridharacharya rule, minus b plus minus root over b square minus 4ac by 2a, then we get this. Okay, if this is solved, then we are getting 2 plus minus 3i. That means its solution becomes y is equal to e to the power 2x into a cos beta x, beta here is 3, alpha plus minus I beta, e to the power alpha x, the solution it has, the complementary function, into a cos beta x plus b sin beta x. Here alpha is 2, beta is 3. So e to the power 2x into a cos 3x plus b sin 3x, where a and b are arbitrary constants. Then the problem that is written here, well, 2d3y dx3 minus 72y dx2 plus 7dy dx minus 2y is equal to 0. Now what will happen in this case? Let y be equal to e to the power mx be a trial solution of the differential equation. Then what will be the auxiliary solution? 2m to the power 3 minus 7m2 square plus 7m minus 2 is equal to 0. Okay, so we have written this auxiliary solution. Auxiliary equation. So we have to solve this. The technique to solve this is to leave this line blank. Okay, here we will check by putting m is equal to 1, 2, 3, yeah, minus 1, minus 2, minus 3, for which value of m this will be 0, for whichever value it becomes 0, suppose if I put m is equal to 1 here, it will be seen that this becomes 0, so m minus 1 will be a vector or a root. So in this case m minus, here the degree of m is 3, that's why I wrote m minus 1 3 times. I will multiply by 2 meters square, then 2 meters cube minus 2 meters square. Here we have minus 7 meters square, that means we have to multiply by minus 5 meters square plus 5 meters, next was 7 meters, but here we got 5 meters, that means we need 2 meters, that means plus 2 into Multiplying by plus 2 gives plus 2 meters minus 2 is equal to 0. So ultimately it became m minus 1 into 2 meters square minus 5 meters plus 2 is equal to 0. Okay, so now if the inner quadratic equation is solved, meaning m minus 1 into 2 meters square minus 4 meters minus m plus 2 is equal to 0, then what we'll get is m minus 1 into 2 meters into m minus 2 minus 1 into m minus 2. Okay, in terms of that, if we add it in middle form, that is in the form of sum of two roots, we will write the product of the two in such a way that the sum of the two or difference results in the middle number. That's what I've applied here. So this will have three roots. See, m minus 1, m minus 2 and 2m minus 1 is equal to 0. So what are the values of m coming out? The values of m are 1, 2, half. So what will be the general solution? Here three are different, distinct. Y is equal to c1 e to the power x plus c2 e to the power 2x plus c3 e to the power x by 2, where c1, c2, c3 are arbitrary constants. Next problem needs to be solved. Solve d plus 1 whole to the power 3 into d square minus 4 into d minus 2 into y is equal to 0, where the value of d is the operator, d is d dx. Okay, so we assumed in the same way, we assumed y is equal to e to the power mx as the trial solution. What will be the auxiliary equation? Well, m plus 1 whole to the power 3 into m square minus 4 into m minus 2 is equal to 0, where wherever there is b, m will be replaced in that place automatically. If we do this originally, if we find these values, okay, then automatically this will come. Yeah, it will match with this. That's why I'm saying that wherever there is a value of d, we will just replace it with m. Then auxiliary equation will be formed. So if this equation is solved, then from m plus 1 whole to the power 3, three roots will come, minus 1 comma minus 1 comma minus 1. From m square minus 4, 2 will come, plus minus 2, and from m minus 2, m is equal to 2 will come. That means ultimately minus 1 is repeated 3 times, minus 1 minus 1 minus 1. Okay, 2, that is plus 2, is repeated twice, 2 comma 2, and minus 2 is there once. So what did our solution become? Y is equal to c1 plus c2x plus c3x square into e to the power minus x. Why have I written this here? Because it is repeated 3 times, meaning it will be the second degree of x. I mentioned this in the previous lecture, c1 plus c2x plus c3x square into e to the power minus x plus c4 plus c5x into e to the power 2x. Okay, since 2 is repeated twice here and minus 2 is there once, so c6 into e to the power minus 2x. Where c1, c2, c3, c4, c5, c6, what are these? These are arbitrary constants. Okay, there's another problem. Let's see. Solve d3y dx3 minus 2d2y dx2 minus 5dy dx plus 6y is equal to 0. Now for this problem, similarly, let's assume that let y be equal to e to the power mx be a trial solution of the auxiliary of the differential equation. So what will be the auxiliary equation? Now whatever order of differential equation is here, differential, whatever order of differential, ये derivative is there. Okay, third order derivative here, here is the second order derivative, here is the first order derivative. So the value of m, the degree of m will be that much, okay. Here the third order, number 3, so since d3 is there, d3y dx3 means 3 times derivative. So here it is m to the power 3 minus 2 meters square minus 5 meters plus 6 is equal to 0. So we will solve it. Here also the same technique. First let's see what value of m will make it 0. Putting m equal to 1 will make it 0. That means we can say here m minus 1 will be a factor. Okay, so if m minus 1 is a factor, then what will we get? M minus 1 has to be written 3 times. After writing it 3 times, we'll multiply. We'll multiply by m square minus m square. Here we have minus 2 meter square. So again we have to multiply by minus m. This minus m square plus m. It became minus 2 meter square plus m. Here we have minus 5 meters. That means we have to multiply by minus 6. Minus 6 m's plus 6. Okay, it's done. So m minus 1 will be common. After taking m minus 1 common, m square minus m minus 6 is equal to 0. M minus 1 into m square. Now we will do minus m. Okay, we will factorize those two. The sum of the two factors should be like the middle one. It's nothing. So after solving this, we will see what the roots of m are. 1, 3, minus 2. Okay, that means what is the general solution? 3 are distinct. So what will be the general solution? c1 e to the power x plus c2 e to the power 3x plus c3 e to the power minus 2x. Why am I calling it the general solution here? Here the right side is 0. That means complementary. This is the complementary function. The complementary function is the general solution, and C1, C2, C3 are arbitrary constants. Okay, I'm ending it here for today. In the next lecture, we will solve more problems. If you liked my video, then please subscribe to my channel.